So yeah, thank you everybody. It's also for me an honor. Also not the first time in Taiwan, but for this show it's the first time, and I'm impressed what is out there. I've seen a lot of shows already, and I liked what Matthew was showing, what Ricky was showing, going into software, going a bit, let's say, also in the semiconductor. So I like actually the flow, because I want to bring a bit of a perspective into this topic, how we see it from Infineon. And certainly, if you think about AI and robotics, AI is about data. And what does it mean with data? We need to store this data, we need to put this data somewhere, and we need to consume energy for this one. So this is one of the themes I also want to give during this presentation today, but of course, going into the AI and also how we are enabling it from Infineon to do so. So AI, I'm not going to stretch here. I think it was a good introduction, already twice done. It's going to certainly change the world, how we know it. We see it basically on innovation side. We see it on the use cases. We at Infineon also use it in our semiconductor factory with robots, also using Intel in some cases, also using software. Maybe with Intrinsic we can do it more, improve the decision making in all the other ways. So it's going to change certainly the way how we are working. And one quote, what I want to bring here also on the possibilities of this AI. And I think it's a really good quote. Maybe some of you have seen it already. I will read it out loud here. Like, I want AI to do my laundry and dishes so that I can do art and writing. Not AI to do art and writing so that I can do laundry and dishes. And this is something I found really interesting, and I think it was from the UK, because this is also the caution we have to put for this AI. It's good to have AI, but we really have to know how to use it. So this theme of safe and secure, and also functional safety for the whole, let's say, robot world that we are in, this will be key. There's no way around, because I don't want to, as well as written here, do more work what I have to do, and the AI do the fun thing, and I think you all here can align on this one. So what we need to do in the end is we need to enable not just the AI, but the physical AI. And this is, I would say, the triangle, what was mentioned today. So I want to like to illustrate it here, how we from Infineon are perceiving it and are enabling it in a few examples. So what you think about the robot, think about the human, which is perceiving, thinking, and of course acting. So perceiving with the sensors that you need all around here. May it be a sensor fusion where you need software to do so. We from our side see here cameras, radar, time of flight or other solutions. Also Intel, in the past I would say really active in Intel RealSense. Now it's a bit of a, I would say, a sister-brother relationship here. So this is the one thing that certainly needs to fall in place. We need to have the thinking, which is more on the CPU, MPU. And one thing to mention here is it has to be all happening safe. So it's not just about having a strong brain, but this brain needs to also be managed to do the right things. And what we have here in place is especially also partnering with leading companies, with our Aurix families. And as you know, Infineon is leading in automotive in functional safety, in powering the whole industry here. So we are certain that we can also contribute here on the powering the safety in the robot. And last but not least, it's about the acting. I heard here by Mr. Hu in the beginning, the actuators or the motion controls is the most far, let's say, in the whole process of this robotics of AI. I would say in some extent I agree, especially for the industry. But as an example, if you look at humanoids and those who are following it, this year there was the first half marathon in China. I think 20 humanoids were running, and just 3 made it to the finish line. And the problem was not the software because they fell, or it was a mismanage of whatever. The main problem, I think 85%, was overheating of the motors, because it's also a new area that we are entering for these robots. They will be enabled by AI to do new tasks, but this task is not what they have done in the past. So in a warehouse or in the automotive factory, you will have the same things to do, but now with new opportunities of AGVs, humanoid robots, it's going to be more dynamic. So this is also one thing that is really, really important, not about today's topic, but something I want to stress that we need to pay attention as well. And all over also connectivity will be the key, and this is also an example I will give you later. that certainly we will have AI on the cloud, but our take here is that we will have it coupled also with the edge. It's going to be a fair mix. We are still maybe not yet there to know when to have it on the cloud, when on the edge. I think time will prove, but we have to be prepared because data, as mentioned, will be increasing, so we have to also manage this one. So AI. We at Infineon, I would say, for those who know it, we are powering the AI. So we have big themes here. We power AI also with big companies here in Taiwan, enabling the whole server companies. We are enabling and providing AI. That's the main thing I will just talk in a second on how we want to do it and how we are enabling it and, of course, using. So we will be also, not say in a way, stupid if you don't use this technology to introduce and improve our efficiency. So let's go into providing and enabling AI and in an extent how we at Infineon see it and to do it. And with that, again, an example. So I know the population is aging, so let's say you cannot find any more personal trainer. You have a robot. It can be also your smartwatch or whatever you have. And what you would ask it simply, hey, what training should I do today? It's a simple task. People pay a lot of money for a personal trainer. You could do this with AI. So just looking at the data again and the power consumption that you need here. And this is an example I found really illustrative when I discussed it with peers in the industry and also with my colleagues is you can go to ChatGPT or any other model out there and ask this question. It will consume you 0.3 watt hours. If you do the same thing on the edge and also with a new technology that we have introduced and will be releasing, which is the Infineon PSoC Edge new MCU, not MPU, but quite capable one, you would basically use 0.007. So almost, I would say 100, not possible, but 98% power savings. And for me, this was astonishing. And this is exactly the area why we thought about, okay, certainly there must be a value for this because saving the planet, I would say, just by not burning coal won't save us. So we need to also do it at the semiconductor industry. So what we see here from Infineon is that edge AI will be on the forefront and that some technologies and some decisions, especially in the robots, are also moving in these directions. Why is this the case? So first of all, if you have everything on the cloud, and I'm not saying we have bad connections everywhere globally, but you always mostly need a connection to some server. You have some latency, and this is, I think, the most crucial thing going forward, the latency topics of real-time operations. We always talk about real-time. What is real-time? 1 second, 1 nanosecond, 1 microsecond. I think real-time is what we humans define. I think there's a definition in the theory how fast the human is actually acting when it sees. But this, I think, would be a key enabler for this robotics and AGVs, may it be AMRs, may it be humanoid robotics, maybe not so much in this cleaning robots, which are quite progressed so far. And what we see here is that edge AI will be paramount in some cases. In some cases, basically, that we do the training still on the cloud, especially when you have complex tasks. This definitely what you can think about. This won't happen on the edge. This will still happen on the cloud. We will have the tasks, the trainings, and the large algorithms running there, and especially the data. But training will happen on the cloud, and you could do certain small things that you put on the smaller, maybe Intel CPUs, maybe Infineon PSoCs to do so. And this is certainly the area that we believe can shape here this industry going forward. So let me give you an example maybe here. It's a bit of a packed slide, I know, but we also want to show that we are partnering, hopefully, with a lot of you during this whole journey of enabling this AI. As mentioned, we have software, but we are more a semiconductor company, trying to work together with partners, Intrinsic, NVIDIA. We're also doing some robotic programs in Infineon. We're using Intel here. And just to showcase you here what is needed on this whole flow technologically wise for robotics. So first of all, you will have the inputs. It doesn't have to be a robot as mentioned before. It can be also some other utilities that you are using on the left side. So some physical information. Then we have to have the perception. This can be by vision. This can be by some other sensing technologies, may it be pressure. We will see also going forward more technologies on the sensors which are going to be in the hand. We mentioned it before by Mr. Hu, how we can sense that we don't break things, how we can replicate the human capabilities also of touch. And this is also what we already see today, and this is also what we are providing with a so-called extensive portfolio for the semiconductors, including some basic software. But I think then this is where the magic will happen, is that you have to have the right semiconductor solutions from the CPU, MPU, but also on the MCU. Certain things will be not all calculated in the brain of the robot. You will have it same as in the car, potentially for humanoids, where you have a zone architecture. For those who are familiar, we have a centralized computing in the car, but this is moving into a centralized architecture. And we already see the same trend in robotics, especially for humanoids, which are more complex, to have each of the limbs decentralized, so to say, architecture. And this is where we see these solutions of PSOC Edge coming into place, which is not just capable to do the computing, but also do it safe and secure. So those who are dealing, of course, with software, you can do it also software-based security, but we also have solutions which is called Optica Trust, which is hardware coded or protected, that you can really enable your software, your hardware to be protected. And on top of that, we have the software tools. We have also the right fit solutions with our partners to basically enable this. As I mentioned before, I don't believe that the edge will exist on its own, but that we also will have a cloud which will be a backbone to support us on this one. So where are we heading actually with this AI? I found this quite interesting. The market overall will experience a really high growth. It's already going skyrocketing. You can see the stock prices of some companies. You should have invested earlier, but we see here about by 2028, 600 billion market, not to crunch you with numbers. And IoT, connecting these devices, 127 new devices, just think about it, 127 new devices are connected every second. Every second. So while I said this sentence now to you, approximately 1,000 new devices got hooked on the net. So this is quite an impressive thing. And this all comes back again as well to the topic what I wanted to bring in the beginning is, it's all data. We need to store it, we need to process it, and we need to make a decision. Will we do it centrally or decentrally? And this is a discussion I think we will also have later. What is the opinions? And I'm also eager to see the opinions here from my peers who have quite some expertise in this area, how this will shape the robotics market. But what does this mean, this two things? The amount of data is growing. I'm not going to repeat it again. But one thing I want to say here again is that we are committed to this decarbonization, also sustainability. I'm still a bit of a younger generation, but I want still to have a nice world in front of me and also for my children. But this will certainly affect how we are doing things, how we are basically powering the solutions. Security. So security is one thing. I don't want my data to be just on the cloud. Unsafe, I think nobody wants. And this is also going to be a key point for robotics. If we make it trustworthy to the users that all the data is secure, that it's kind of fail-safe, we will certainly have an even bigger usage of AI, of robotics, of even any usage of helping us outside of the robotic space in our everyday lives. And the last one is the connectivity. Yes, we want it to be seamless. So I don't want to kind of bother around that my robot cannot kind of transmit it there. So also here we're lucky from Infineon, since we acquired Cypress Semiconductors with the solutions for wireless connectivity, that we can enable these solutions here in a kind of more connected and safe way. So what we see here from Infineon certainly is that things are on the cloud, things going to be on the cloud. But one trend that we certainly will see is that edge AI will be something that I would encourage you to look also into. Not just trusting, hey, I have a software, it runs on the cloud. You can do it also on the edge. And lastly, also to mention, yes, AI is important. Yes, software is important. Yes, safety in this whole thing is important. But for robotics especially, it's not just about the software or the brain. You also need the motion. And I think this is something that I want to stress here. If you see a request maybe from research institutes or somewhere else, we from Infineon are committed to this market, not just from the AI, but also in the whole actuation, also in the whole powering, and also in the whole enabling of it. So what I want to bring you today is, from our point of view, is we are not just power, we also have the connectivity, we also have the AI. So if you have any projects, let's drive it together. And I'm curious and open to have a discussion later on with the fellow colleagues here to see what is able and what we can achieve together. So with that, thank you very much. It was an honor to be here. Thank you.